So today's notes are going to look at the amplitude of a trig function. And if you take a look at the coefficient in front, which affects the amplitude, you can see that essentially that is a vertical expansion factor. So if we sketch the graph of sine x, actually I'll do that in black here. We'll do sine x. The graph of sine x is going to go up, down, back, around here, and that's going to be based on an amplitude of 1 from there. Okay, that's going to be from 0 to pi. If I look at the 0.5 sine x, that is a vertical compression of 0.5, so that should give us an amplitude that looks like this. The zeros don't change. Okay, so we end up with an amplitude of 0.5. So if I change that coefficient to a 2 sine theta, I'm going to now increase that amplitude by the same amount, but the zeros stay the same. And I have an amplitude of 2, which matches the coefficient. So the amplitude of the function is affected by that vertical expansion factor. So the effect of A, that A generally we'll say is our vertical expansion compression factor. We also know that that also will affect the orientation, so vertical flip. It will also do a vertical flip if the A is negative. So the A coefficient is an expansion compression factor, but it also indicates the amplitude of the sine and cosine function. Okay, because that is a convenient way just to see, oh, my amplitude starts at 1. That multiplier will compress or expand from 1, so essentially that multiplier is our amplitude. So graphing -3 cos x, we can first of all just think of what does cos x looks like. Okay, our cos x function is going to start at 1 at 90 degrees, so we're going to say this is pi here, 180. It's going to go down to -1, go back up to 0, and back up to 1. Okay, so that's going to be -1, +1. If I'm going to graph my vertical expansion of 3 with a flip, it won't affect my zeros, the middle of the graph. Okay, that's not going to affect the middle of the graph, but it'll affect the vertices. So this +1 vertex ends up at -3. Okay, this -1 is going to end up at +3, somewhere up here. Okay, we're going to go to 0, up to +3, back down to 0, and then through the next quadrant it should go back down to -3. So that's a vertically flipped and stretched graph of cos x. So that is going to be our vertical expansion, compression, and flips. We can also do the same horizontally. Now, horizontal compressions and expansions are to do with the coefficient inside the function. Okay, so we're going to call that b. So we can stretch and compress based on that b value there. And if we think of that as a compression expansion factor, well, times 2 really means compressed by 2. So what we're going to do is we're going to divide the original period of 2 pi by that compression factor. Okay, so times, since x is opposite, ends up as divide. So that's how we can figure out our period. Vice versa, if we actually look at this formula, we can switch the t and the b, and we can actually use the same formula to calculate the b value, the compression factor, based on the actual period. Okay, so this is very handy. So you should make note of that we can actually rearrange that, not only to calculate the period, but to also calculate the compression expansion factor. So graphing this function here, okay, we have our basic cosine graph. Okay, it's going to look like this. Starts at 1, ends up at the bottom is -1, and it's going to go from 0 to 2 pi. Well, if I'm going to compress this graph horizontally, this graph has a horizontal compression, what's going to end up happening is I'm going to go through my full period from 0 to pi. That means everything gets compressed, okay, in between this point and that point. So what am I looking for? I'm looking for basically the 4 quadrants. I'm looking for where it goes to 0, where it goes to its minimum, goes to the 0, and goes back up to its maximum. So what I can do is actually just kind of split up that start and end to its 4 quadrants. So there's 4-part symmetry involved here. I'm just drawing in those lines, just gives me an indication or a guideline to where my 4 quadrants are. Well, in this case, I can go, there's my start, there is my first quadrant to 0, there's my second quadrant to the min, there's my third quadrant to the middle, and there's my fourth quadrant to the max. And I can see that my max is at pi. My minimum value, and these are the coordinates that you're going to need to be able to keep track of. That minimum value, the coordinate is going to be pi over 2. And we can see that these other coordinates are the quadrants, so we can just say that they're halfway between these points here. So halfway means average, so the average of 0 and 1/2 is 1/4. The average between 1/2 and 1/2 is 3/4. Right? I can add and divide by 2 to get the middle coordinates. And I'm going to encourage you to use the middle calculation to be able to find those points, because the nice thing about circles is there's this 4-part middle symmetry. Okay, and we're going to take advantage of that when we're graphing these. So, just like with our first unit, when b is greater than 1, we were talking about a vertical compression, horizontal compression. Okay, it's the opposite of what we see with the y's. If it's divide or b is less than 1, we know that's an expansion along the x-axis. So in this case here, we're dividing, that expansion factor is a divide. So timesing by 1/2, so it's going to be a horizontal expansion. So the period, if I want to calculate, I can use my formula like that, but we know the period basically doubles to 4 pi. So that's key when I'm graphing this then, because when I graph it then, if I know what my period looks like, well, there's my original graph. I'm just going to sketch in my original graph. Let's just compress it a little bit. So there's 2 pi there. I know it's going to go to the middle. Do a little bit nicer than that. Go to the middle. Okay, go down to the bottom, back to the middle, and to the top. Okay, so there's my 4 quadrants in here. If I want to know what this new graph looks like, well, I know it's a horizontal expansion, and I'm just going to draw 4 pi right about there. So 3 pi. Okay, those are my other pieces. And I know I'm going to start here. It's going to expand horizontally, so I'm going to end here. And if I want to draw this in, it's really nice to again have that 4-part symmetry, or my quadrant symmetry. So I want to know what is halfway between 0 and 4 pi. Well, I know my midpoint is right there at 2 pi. I know halfway between 2 and 4 is the average of 2 plus 4 divided by 2 is equal to 3. That gives me my quadrant, and I get my middle here. And most of you would have probably figured that out, could have just kind of seen it based on those numbers. But as we get more complex numbers and complex fractions to work with, I do want to again encourage you to think about the idea of middle. So I've got using middle, I've got my 4 quadrants here, and I'm just going to sketch in my graph now. I know it goes through one quadrant to the middle, okay, through the next quadrant to the bottom, through the next quadrant back to the middle, and to the last quadrant back up to the top. So there's my graph. Okay, it's got a period of 4 pi and has all my quadrants in symmetrically laid out. So same thing here. In this case here, the compression factor is, the coefficient is 1/3, so it's an expansion by 3. So my period in that case is going to be 2 pi over b, or expand by 3. Okay, it's the same thing. So if I draw my original sine function, okay, I'm just going to draw my axis here, and I'll let this be my original sine function. It's going to start here, it's going to go up, back to the middle, down, and back up to the middle. There's my original sine function. I'm going to have to scale this slightly differently because it's not going to all fit in there. So I'm going to redraw this. So I'm going to say that this is 2 pi here, pi here. So those are my quadrants here. So I'm going to go up one quadrant, down in the next quadrant, down in the next quadrant, and back up. So there's my sine graph, my original sine graph. Now if I want to apply that expansion, okay, well, I know that my graph's going to end up, start at 0, and it's got a period of 6 pi. So I know it's got to end here. So it's going to start here, end there, and I need to be able to draw my 4 quadrants. So what I'm going to do is just give myself some guidelines here. So there's my middle. The middle is going to be at 3 pi. Halfway between 3 and 6 is going to be 3 plus 6 divided by 2, which is 4.5, or 9 pi over 2. There's my quadrant there. Halfway between 0 and 3 is going to be 1.5, okay, which is going to be 3 pi over 2, or 0 plus 3 divided by 2. And now I have my quadrants. There's my quadrants. Those lines are just indicating my quadrant boundaries. I'm going to go up to the middle, to the bottom, back to the middle. There's my sine graph. I have my 4 quadrants. I've clearly indicated my middle points and my vertex coordinates. Okay, I should maybe make sure that's clear. That's going to be at -1 and 1. Okay, and there it is. There's my expanded sine function.